Here, we'll be talking about what is DevOps, what is DevSecOps, and what is GitOps. What exactly do they mean and how do they relate to one another? Now, in the beginning of this semester, we've talked about how computers have evolved from the early days of Charles Babbage to using telegraph to using quite a lot of things to today where we have trillions of devices. Well, maybe not trillions, billions of devices that need access to the internet or that are communicating or doing some kind of processing, have chips in them, have some form of computing in them, and they process data. Now, remember when we were doing IP addresses, the initial design of IPv4 assumed there would be need for only 4 billion IP addresses in the world. But now we have serious scarcity. And that was why IPv6 was introduced. That's to show you how constantly the world is evolving. But all of this only happens because of software engineering. Software engineering is that field. Oh, you have your computer, then what next? How do you make your computer do what you want it to do? How do you make your phone to do what it was to do? When your phone was being built as a device, it's just a device. It needs an operating system. It needs all the applications that you are downloading to run, to function. It's something that is picking your voice from your microphone, encoding it, converting it into packets within your phone, and sending it over wire. It's something that is doing it, and that is the software. But how do you make the software? It's not just by writing or programming. It's a process called software engineering. It comes with planning. It comes with analysis, sitting down and listening to stakeholders, which can be customers, which can be your team members or your organizations. Defining what needs to be done, identifying the different components that needs to be done. Then you go straight to development. When development is happening, more changes are being introduced. Then deployment. From deployment, you go to testing and so on and so forth, and the process keeps evolving. A lot of steps are involved when doing software development. But in the initial days, we have, or even up till now, we have what we call the software development lifecycle. And it involves right from the stage of you having an idea of something you want to do, straight to you maintaining, deploying it, and maintaining it as you go. You have a startup idea. That's the ideation stage. Then as you build it, as you work on it, you do the planning, you do the building, you do the testing, deployment, maintenance, and keeping everything running. It's a life cycle. And that's what we call the software development life cycle. As an infrastructure engineer and also a systems administrator, you spend a lot of your time in the deployment stage, but you will also be a part of the remaining of the development life cycle. Now, in the beginning, a lot of development uses the waterfall model. The waterfall model is where you start at a stage, which is, oh, we have an idea, then we sit down, we plan, then we do analysis, then we do design. Every step waits for the order to be complete. But that is not sustainable because it takes a lot of time. And because things change, the waterfall model is not built to accept as things change. That is why the world moved to Agile. In Agile, tasks are broken into smaller pieces and they are iterated over continuously. As new requirements are coming in at different stages, they are being introduced until development is complete and deployment is done. But often, all this is involved in software development, where the actual development of a solution is done. Then when deployment happens, it ships off and the development team focuses on something else. But that is where DevOps becomes better than the rest, because DevOps involves a collaborative effort between the development team, the operations team, and the quality assurance team. They all work together to ensure that all the development, all the ideation, and everything that is being done within the organization, everyone is part and parcel of it. Basically, DevOps isn't just some technology somewhere or some tool software that you need to use. It's a complete culture shift in how you think and how you process things. Basically, your engineers, your teammates, with the processes you have on ground and the technology you are using are what makes up what we call DevOps. Now, if we compare Agile and DevOps, Agile basically involves, okay, we've started a project. We are iterating and iterating and iterating and iterating over it until we get it done and we get it shipped. And most often, we forget about it. But when it comes to DevOps, there's constant iteration. And as soon as one is being done, more changes are being introduced and it keeps running. It's a continuous circle that keeps evolving. Now, because it's a continuous thing, and with the way software development has evolved now, especially with the pandemic, things need to move fast. Solutions need to be created, and we need to be able to respond to changes. That is where continuous development life cycle comes in. This involves a process whereby, as you have a lot of team members in different places doing different things. Everyone is building their applications, doing all the necessary work. Then, as they are building more tools, there needs to be a way, using Git or using some version control, there needs to be a way that all the different bits and pieces that they are all working on are mashed together to work together. But once you are merging them, they need to be tested so that someone doesn't introduce something odd or out of the ordinary or buggy or with vulnerabilities into it. That is where you have continuous testing, continuous security analysis. Then this evolves to continuous governance to ensure that there are certain policies, certain rules that have been set by the organization, like, oh, this NPM package, we don't use it. This software with this license, we don't use it. This is what we use, and that is what we use. Then we have continuous deployment, where as your developers are working on the application, you, the systems administrator, or the CI engineer, or cloud engineer, or DevOps engineer, have already planned your CI/CD pipeline, continuous integration and continuous deployment pipeline, so that as applications are being integrated, they are being tested. As soon as the tests are passed and everything is fine, they are automatically deployed to staging or to some other environment. And when you are done, we have continuous delivery. That is when fully tested applications move from staging or move from testing onto production. Then there's continuous monitoring to ensure that applications are running as much as they are supposed to and as efficiently as they've been planned to. Whenever things go wrong, automatically, there are tooling and resources that will immediately create an issue or create a ticket or create a Slack notification to tell you that something has gone wrong, we need to fix it. Now, but DevOps involves a lot because you have a lot of stages between the life cycle. It means you have to bring a lot of toolings. Oh, you use Visual Studio Code for your development. You use maybe Jenkins for your continuous integration, testing your application. You use Snike to make sure security vulnerabilities are detected. You use another application for monitoring. You use AWS and everything for different things. It can be massive for you to be able to maintain a lot of toolings. Licenses you have to subscribe to, payments you have to do up and down, and a lot of other things that you have to make sure are in place for all these tools to work with one another. That is where DevOps platforms come in. Now, and one of the most prominent among them is the GitLab DevOps platform. It's a single, instead of having a lot of tooling that you have to ensure work with one another, a DevOps platform provides everything you need for the whole of your development lifecycle, right from ideation of having an idea to planning, to doing your analysis, discussing about it within the team, to implementing it by coding, up to verifying to make sure that every component that are being introduced are fully tested, to packaging it. We've seen how you build your Docker containers, to building these Docker containers, to testing all these containers to make sure there are no vulnerabilities in them, to pushing them out. The way you saw we deployed with Kubernetes. We created deployment with an image that we've created. To configuring and monitoring and protecting an application, a complete circle that means everything is constantly tested. New problems that are coming in are verified, created. Problems are solutions are introduced. Those solutions are released, they are tested, and they are pushed forward. But then that brings in DevSecOps.